Hey guys, welcome to my channel. I don't know how you got here, but I do hope that you'll stay until the end of this video because in this particular video, we're going to talk about computation tables. Specifically, I'm going to teach you guys how to create a computation table. So what I'm going to be using is Microsoft Office Excel, but there are just minor differences from other applications and software such as Google Docs or spreadsheets. So the commands I'll be using are somewhat interchangeable. So hopefully, after the end of this video, you'll be able to use what I teach you on your various projects, huh? So to begin with, let's go ahead and start laying out the computation table. Let's go ahead and zoom in just a little bit. I'm going to go ahead and just use Arial font, Arial, Arial. I don't know how to pronounce it. And we're going to use size 12. Okay. And for here on the top, we're going to take 3 rows here. And we're going to go ahead and just make them bold. And here we're going to go ahead and freeze those top rows. So we click on the row right beneath. In Microsoft Excel, we go to View, Freeze Panes, and select Freeze Panes, and that'll just like keep the top rows frozen. So that means when we start scrolling down, we don't have to figure out where we're at on our computation table. I believe in like other softwares, the option to freeze the panes are set up differently. So I can't help you there. I'm sorry. But anyway, you're going to find that because I did make a previous video about computation tables, and you're going to find that I'm going to change some of the terms a bit because when I made that video, that was just based on like notes I made when I was in college. And I realize now that the reason I made that video was to help people that were confused when they were taught how to do it because I was confused when I was taught how to do it. I had to actually do more self-study to figure it out. And I think some of the problem was because of the terms that were used. And for this video, I'm going to use more relatable terms so that we can kind of understand how the computation table works. Okay, so we're going to go ahead and start setting up our rows here. I'm going to use the second row here. We're going to go ahead and title this type of space. And we need 3 columns for that. 1, 2, 3. Next one, we're going to have the users. For this, we need four columns. So 1, 2, 3, 4. Next, we have furnitures and fixtures. Furnitures, fixtures, equipment. Okay. And we need 5 rows for that one. So 1, 2, 3, 4, 5. And here, the end, we're just going to go with totals because I can't think of another word for totals. Some products, some summarization, I don't know. Okay, so types of spaces. For the first column, we have name of space. Second column, purpose of space. And third column is amount of spaces. Okay, so let's go ahead and spread this out a bit so we can kind of see what's going on. By the way, for the totals, you're going to need four columns, I believe. So column width, let's go ahead and make it 15. Is that going to work for us? And what we're going to do is we're going to go ahead and wrap text. That way we can see all the words, yeah? Okay, so this one we're going to go ahead and merge and center. So there's still a lot of editing you have to do in order to make the computation table presentable. Okay, so there. So now we can just scroll down and no problem. So types of users. Last time I used the terms static, pedal, and pivotal. And I don't know why. Static, pedal, and pivotal. So to be honest, I don't really know why. I don't like these terms. I never even during college I didn't really like these terms because they don't make sense. When I think of pedal, I think of a bike. When I think of pivotal, I think of something major that happened in life or something. Doesn't make sense. So let's go ahead and just change the terms. Now, the thing about the titles of these columns is it doesn't really matter uh, what words we use. What matters is do the words convey what we want it to mean, you know? So I don't believe these words convey what I want people to understand. So I'm just gonna, actually the only term that makes sense here is static. And the reason we needed to know the type of user is because we need to know the type of movement, which is kind of one of the important things about the understanding of the computation table. So actually, I'm going to go ahead and keep the term static, but I'm going to use a second term, a second word, movement. Uh, for this one, I'm going to say marginal movement because I think that sounds better. And this one we're going to say constant movement. Now that makes more sense, doesn't it? Is it just me? Marginal, so static movements, the term static just means like you're not moving. So static movement is, let's just say you're kind of making static on the carpet or something. You're not moving that much. You don't have to move that much, basically. Marginal movement is like saying slight movement, not too much movement. Constant movement, you're constantly moving. So that makes more sense to me. I believe it makes more sense. So we're going to go ahead and go with that. And here on this final column, uh, we need to know the total amount of space, right? Total amount of space, mm, total amount of area. We'll use the term area because I don't like to be redundant. Also we have space in the first area, which kind of makes sense because it's part of a space programming. So, but we're gonna go here and say area, and I work with uh, square meters, so I'm gonna go ahead and put square meters. Total amount of area in square meters. Okay, so this kind of makes more sense to me if you ask me. I'm going to go ahead and put borders on the left and the right. Yeah, I hope that's cool with you guys. Right here. And we'll get into the totals later. Oh, wait, that was a mistake. We need all of these right here. Yeah, there we go. So for furnitures and equipment, we're going to have the name of, excuse me, we're going to have the name of the furniture, fixture, equipment, right? Next, we're going to have the depth, or actually, we're going to go with width. We're going to start with width. We're going to have the width and the depth. I like to use the terms width and depth because when you use length times width, it kind of gets confusing because length is kind of interchangeable with width. Like if you look at a rectangle, either side can be length and either side can be width, to be honest. But when we look at it, when we look at an item, you know, we have width and depth. We can say that it's this wide and it's this deep, you know, so it makes more sense. It's not as confusing because, for example, what we're trying to do when we use words to describe something to another person is we want to make sure that they understand what we're saying. And if we say like the length of a lot is 5 meters, uh, it doesn't really make as much sense as when we say the depth of the lot is 5 meters, because now we know that it's 5 meters deep from the front. Here in the middle between width and depth, I just have an X, and that's just to indicate that it's width times depth. No? Easy. And total amount of area in square meters. Once again, simple. Okay, now for the totals. So I said I believe it's 4. Uh, Here we have the uh, total net space, total net area, let's say. Gross area, net area. Total net area. Um, I'm not really sure what term we can use here. Mm, let's say computed area. Here we have the multiplier. I can't think of another term for that right now, so we're going to go ahead and stick with multiplier. Here we're going to have, oh, okay, computed area for space, for the space, all right? Okay, and then multiplier and computed area with consideration in square meters. So this is also in square meters, right? We'll call this one, instead of multiplier, multiplying consideration multiplier. That way we have a bit more understanding of it. And the final will have total needed area in square meters. Okay, so I hope that makes sense, or I hope it'll make sense in a bit, but let's go ahead and merge these. Once again, we're going to go ahead and add there. Okay, so we have all those now. Let's go ahead and just shrink it a bit. Just a bit more so we can see everything on the screen. Okay, so we have the type of space. I believe that's self-explanatory. User, self-explanatory. Furnitures, fixtures, equipment, self-explanatory. Totals, not so self-explanatory, so I'll go into that into more detail on that a little bit later. But there, we have our basic columns. So the thing about Excel or spreadsheets or Google Docs worksheets, sometimes it's about what you don't see. So in this instance, there's definitely going to be some things that you won't see. What we print out is just what we need the client to see. I'm going to go ahead and merge this here on the top. Okay. And in this instance, so last time I mentioned that each of these users needs a certain amount of space. Static movement, I tend to use 0.6 square meters. Marginal movement around 1 square meter. Constant movement around 2.7 and or more. So how do I come up with this computation? I'm gonna use the Excel sheet to kind of explain it to you guys. Now let's just go ahead and zoom in somewhere. We'll go ahead way over here so it's more understandable. Okay, so right here somewhere. The idea is when we indicate the kind of users in that room, we're already describing how much space we need. The reason I use 0.6 for static is because they're not technically moving that much. And to be honest, 0.6 square meters is a bit much because the amount of space that I need right here, for example, I have my trusty metal ruler here. So for example, this metal ruler is 450 millimeters or 45 centimeters from start to end with a bit of extra for the loophole or the keyhole, whatever you want to call it. But if you look at my shoulder width, This is like the best representation I can give you. I am roughly uh 45 centimeters wide, roughly. And I'm not really that big of a dude, you know. I'm just pretty average, pretty below average actually. I'm not that amazing. I'm below average, let's say. So if you can imagine an average person is probably going to be a bit bigger than me. But then again, I do have these amazing shoulders. No, I'm joking. You can imagine that a bigger person than me will probably be a bit bigger. So they're probably, if we want to go at a safe range, I'd like to say zero point 0.6 square meters, you know. So if we like take that into consideration, we add another zero point 0.2. Yeah, where am I? 0.2 meters, somewhere around there. So that width is big enough for the average person, right? Where's the camera? There we are, right? Um, that width is big enough for the average person. And then if we add a bit more to it, like so the square root of zero point 0.6 is around 0.76, 0.76, 0.77. We can say that this person can at least spin around. Okay, but in all honesty, if you consider, if we're gonna say like what's a better space for a person that's not moving, zero point 0.6 by zero point 0.6 is pretty reasonable. That's why you'll also find, like, for example, when you ride on a bus, they're trying to make it as compact as possible to fit on the road. And you'll find that sometimes you're just squeezed in there. For me, I can sit on a bus quite comfortably in terms of width and space and depth because I'm not a big person, but a bigger person obviously would complain. I'm not saying that they would complain. I'm just saying like they would have some complaints. They'd have some suggestions. Let's say sorry. No, I don't want to be negative. They'd have some suggestions like maybe make it a bit bigger, which would still be more favorable to me, you know. But the reason for that is because they need to fit as many people as possible in this public mode of transportation. So they just kind of go with point 0.45 by point 0.6. So 0.45 by point 0.6, how big is that? 2.4 plus point 0.3, point 0.50 something. Oh my gosh, I have Excel in front of me. Why don't I use it, right? So let's say 0.45 times zero point 0.6. 0.27. Yeah, so I was right. 24 plus 3, 27. Okay, so 0.27 is a reasonable amount of space, but it doesn't sound like enough space, does it? And if you think about it, if we go even smaller than that, we can say that if we go into like the most minimal, 0.45 by 0.45, which is, or 0.45 by zero point 0.5, let's say, 0.45 times zero point 0.5, it's even smaller. Um, but as we go up in the scale, so let's say we go zero point 0.6 by zero point 0.6. So that's a decent amount of space, zero point 0.6 by zero point 0.6, because that's already enough for, you know, at least for me, that's enough for me to move around a bit more. We go even further than that, we can go zero point 0.7 equals zero point 0.7 times zero point 0.7, 0.49. So now we're getting closer to the number that I use. So zero point 0.7 by zero point 0.7, if you think about it. Um, so this is 0.35, which is 35 centimeters right here, right, guys? Times that by 2, right? That's pretty decent, right? For a person that's just sitting by themselves, especially for a person my size. We go a bit further, equals 0.75 by 0.75, 0.56, 0.25, and we round that up as 0.6. So that is the reason I use 0.6, because for me, that's what makes sense. And whenever we um, whenever we defend ourselves with our computation tables or whatever facts we bring it up, we always provide data to ensure that the people that we are explaining to explain our reasoning to understand why we do what we do. When you don't explain it to them properly, then they have a lot of questions, you know. So for me to use zero point 0.6, it makes zero point 0.6 square meters for a person that is static, not moving. It makes sense to me, and I'm pretty sure it would make sense to a lot of people to use 0.75 by 0.75 uh, meters, compared to using the minimal possible space that a person needs, which is 0.45 by zero point 0.5. So if you can imagine, a person that's like a little bit bigger than me would already have a hard time fitting in that space, especially with it being static. Unless they have to be standing, they'd probably be a bit comfortable, but then they have that term. It's like being in a can of sardines, where we're the sardines, and that's what we don't want. So that's why, for me, I go with zero point 0.6. For the marginal movement, I use 1.2 square meters, or 1 square meter. So obviously, it's just 1 meter times 1 meter, 1 square meter, and that's a lot of space to move around. For And the marginal movement is just, kind of, you're not really extending that much. It's just doing marginal movement. But you can go a step further than that. So let's say that a person's wingspan is really wide, and let's say that the project you're designing is a house for a basketball player, or a football player, an athlete that requires to be, an athlete that is quite large, quite big. You're working on a house for someone that's 6'6" or taller. Wingspan is a bit different. This is why you have to do your research before you make a computation table. So let's say uh, you're working on this house for an athlete that's 6'6", somewhere around that range. Obviously, their their mass is going to be quite different. So that means their depth and width is going to be quite different. So maybe that 1 meter that will work fine for me and the average person is not going to work well for them. So what do you have to do? You have to make it larger. And this is how you defend your project, by giving them details, giving them the proper facts. So let's say that you made it 1.5 by 1.5. So now it's 2.25. You see the difference in square meters is quite large. And with the final one, constant movement, where they're just kind of moving around all the time. Like I said, I use 2.7. Um, I can't really figure it out on the top of my head, so let me just see what the square root of 2.7 is. 2.7 square root of that is 1.6. So 1.6 square meters, or 1.6 meters. So equals 1.6 times 1.6 meters, 2.56. So somewhere around 2.7, right? But obviously, you can still go further than that. So let's say that you want to go equals 2 by 2 meters, 4 square meters, and it just keeps going further and further. So if we're going to you have to understand that when you make your computation table, it's not always going to be uh, the same constants. It's not always going to be the same variables. You have to make sure that you adjust depending on the need of the project. So like I said earlier, if you're making you're making a locker room for people that are going to be taller than average, then obviously you have to make the space bigger than average. You can't just use the average space of average health club, or the average high school gymnasium, which is another thing. If you're going to make a locker room for a high school, you're going to have to use smaller spaces. And the best way to understand like these different sizes and shapes and lengths that we need to use is to study anthropometrics, and Anthropometrics, is that right? Anthropometrics. So that is the study of the measurement of capabilities of the human body. And another term that you want to probably use is proxemics. So let me go ahead and type that here for you guys. Anthropometrics. Spread it out. Bam. Anthropometrics. And the other word, proxemics. These are two words you should look into figuring out the different lengths that you need to work with when you design for your project. So let's go ahead and go back. I hope that gives you guys a clearer understanding of why we use certain measurements for these things right here for the users. Okay, so like I said earlier, sometimes when you make a table, it's not about what you see. Sometimes it's also about what you don't see. Here in this particular table, there's going to be a lot of things that we don't see. So for example, let's go ahead and sorry, let's go ahead and zoom out here. So out here in the realm of the unknown, or out here, let's just say, I'm going to go ahead and put here. This one, we're going to go ahead and we're going to title it static movement product. And here we're going to call it marginal movement product. And here, constant movement product. Okay, so we have the three products. What is the product? If you don't know, the product of two numbers is when you multiply them. That's the answer. We're going to go ahead and change the width to 15. That's fine. So these three columns, we're not going to see when we print out our computation tables. These are always off to the side. Actually, you can also put them in another sheet. If you use like different programs, because I've worked in offices where we do use different kinds of spreadsheets, and it's kind of difficult to set it up so that you don't print this with them. So I always put it in a different sheet. So you just have to adapt to whatever program you're using. And in this slot, we're going to go ahead and just use my standard square meters, 0.6, 1.2, or 1 meter, and 2.7. That's fine. Did I use 2.7? I feel like that's still kind of small. I'm just going to go with 3. 1.2 and 3. That feels a bit better. So here, we're going to go ahead and say this is equal to, we're going to go ahead here on the first number, static movement times 0.6. Enter. Easy. Very simple. Here, we're going to do the same thing. This time we're going to use 1.2. So here, we're going to use the marginal movement. We're just going to click on this one times 1.2. Enter. Done. Here, we're going to do the same thing. Equals constant movement times 3. Done. Easy. So in this slot, we can actually put here. So Alt Enter, because if you press Enter, it's just going to get out of the cell, right? You press Alt Enter to go to the next paragraph. Is that right? I don't know how to say it. But we're going to go ahead here and we're going to go ahead and put, oops, sorry. We're going to go ahead and put 0.6 square meters. That way it's understood, right? Go ahead, go here, Alt Enter. Once again, I'm going to put here 1.2 square meters. Okay, and finally, we're going to go here, F2, and then we're going to go Alt Enter and 3.0 square meters. That way, it's understood when we print it out, like what our constant is. And these right here are going to be our variables. So total amount in square meters, we are going to go ahead and go equals, open parentheses, and we're just going to highlight these three. Close parentheses, enter. It doesn't have a value. Why? We don't have anything going on yet. Oh no, what happened here? Equals the sum. Don't forget to put that. Equals sum, open parentheses, and then you pick the three numbers. Close parentheses, and enter. Okay, so let's see. We're going to test it out now. We're just going to put 1 here, so that's 0.6. What if we put 2? It should be 1.2. Good. And we put 3, 1.8. Works fine. We can go ahead and test that with the other ones. 1, enter, 1.2. Good. We're going to go ahead and delete that. Here, we're going to go ahead and put 1 here. 3. Good. What if we put 4? 12. Good. So, in essence, it works. Now, we only did that for 1 row. How do we do it for the next 100 rows? That's simple. So we just select the rows that we want to copy. And the reason I only did it for 1 row is because if we do it for multiple rows, it's kind of going to get messy. But if we do it for 1 row and we just kind of go here, select it, and drag it down, and we'll just go ahead and drag it down to as far as, let's say, 1,000. Down, 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 down. Almost there, guys. 1,000. You want to make sure to drag it down as far as you can. So you don't have to be this meticulous. Actually, when I make these, I just drag it down, and then wherever it lands, that's where it lands. And there, 1,000. There. So we got all the numbers set up there. We're going to go ahead and scroll back up. Boom. Do the same thing right here. This time we're going to select the 3. Then we're going to go ahead and click on the little square on the lower right. Once again, all the way down to 1,000. Bam, right there. Perfect. So now we don't have to worry. We don't have to worry about typing it in one by one. Isn't that great, guys? It's there. That's all there is to it. No problem. So next, what I'm going to do here is we're going to change the width of these guys. Column width to 12. Let's see how that works out. No. Column width 13. There we go. Let's see how it works out. No, column width again. I want to like take up as minimal space as possible. So that's going to work right there. Okay. These spaces are probably going to take up the most. Right here, we can go ahead and change this column width to 14 as well. Or maybe less, actually. Column width, 14 is fine. Cancel, sorry. And here, name of space, let's go with 20 or 25 maybe. Purpose of space, column width. Actually, you know what? 20 is fine. This one will go with 30. This one will go with 20. Perfect. Okay, so you can't see the rest of the table here on my thing, but that's okay. What we're going to do here is we're going to go ahead and center these. So center, center, bam. Or actually, you know what? Let's just have them all on the base. All centered. Name of furniture equipment, column width. We're going to go ahead and call you 20. 20 is fine. This one right here, column width. What is it? I think 5. That's still too much. Column width 2. Yeah, that's totally fine. And here for you guys, column width, we're gonna go ahead and go with 10. Not that we don't need that much space for those guys. Column width right here. Let's go with 14. Okay, so now it's looking more and more organized, right? So now I'm gonna change these right here. These guys. We're going to. We can either say. Let's see here. I'm not quite sure, but I know that for other programs there's a different command. But in this one, we can go ahead and go here to our format, number format. And I'm going to change it to a number. Okay, so now you can see that it's added 2 decimal places, which is perfect. So we want everything rounded, right? The thing about this, though, keep in mind, is that, for example, you have 0.94. 0.944 is going to be 0.94, right? And then in the next line, you're going to have 0.95, 0.954, which is going to be 0.95, right? Or let's make it simpler for ourselves. We're going to have 0.0. I'll put it right here so you guys understand what I'm trying to say. So let's say we have here 0.044, and here we have 0.0454. Okay. The sum of these two numbers is, if we're going to round them down, it's going to be 0.04 and 0.05, which is going to equal 0.09, right? But when you add these two, it's actually going to, when you add these two as they are, 0.044 and 0.054, it's going to equal 0.098. And when you round 0.098 up, it equals 0.1. So that's kind of the downfall of using Excel as the basis of your rounding of numbers, because it's not going to round the summations. But we're not going to make that a big deal for us unless we're like using specific scientific calculation. Well, technically this is a science, but we're kind of trying to do this in the sense that we're trying to finish our project and we still get the same output either way. So anyway, I know I'm giving you too much details, but I just want you guys to learn. So anyway, we have that down. So here we have width times depth. So obviously right here, we're going to go ahead and equal product. So product is when you multiply two numbers. So we're going to go ahead and click on this. And then we're going to click on this. And then we have to click down on control, because otherwise it's not going to capture this one as well. It's just going to separate. So we have to click on this, press down on control, click on this. Now we have two numbers. Close parentheses, enter. There, we have our number, which for some reason, this didn't become a number. So let's go ahead and put that number. Yeah, right there. This should also be number, number. Good, good, good. So everything there, number. Alrighty. Okay, so we're almost done, guys. This one, we're going to do the same thing, drag it down all the way down to 1,000. Now, there it is, 1,000. All good. Okay. Whew. Almost done. Computed area for the space in square meters. So in this row, we have here the amount of spaces. We're not going to consider the amount of spaces. We're just going to consider the computed space for one of these areas. So what's going to happen here is we're going to take, this is going to equal, we're going to go ahead and go out here into the unknown, the realm of the unknown. All right. Let's go ahead and go into our realm of unknown right out here. Right here, we're going to go ahead and go for computed space for 1. Okay, so that way it makes some sense. Column width, go ahead and make that 15. Let's go ahead and make this one 2, just that we have a space in between. And we're going to go ahead and put here equals equals sum, open parentheses, of oh, sorry. This one we're going to have just equal. We're not going to compute it yet. It's a bit, this is where it kind of gets a bit confusing. So, but in this one right here, we're going to go ahead and put equals sum, open parentheses, of this, and then we're going to hold down Control to add up another space, and this. Okay, enter. Bam. So we got that. And right here, all the way back down to 1000. 1000, go back all the way up. Computed space for 1. For this one, we are going to have to do this manually. And I'm going to show you why once we finish making our computation table. So here on the consideration multiplier, we're going to change this type to a percentage. Percentage. So that means when we put down a number, it's a percent, right? Okay. Then what we have here is we're going to go ahead and equals sum. Okay. Or sorry, equals product of consideration multiplier. Oh shoot, sorry. It's starting to get confusing, guys, isn't it? Product, open parentheses, consideration multiplier, and computed space for 1. Or computed area for the space in square meters. So this one right here. Bam. Okay. Once again, we're going to go ahead and get this, drag it all the way down to 1000. So Excel is a very fickle, very fickle lady. And we're kind of I'm gonna show you that problem in a moment. So the thing about Excel is it's still just a program that runs on what we have to feed it. So you'll see what I mean eventually. So total needed area, we're going to go here, equals product again. Product, open parenthesis. And this time, we're going to go here to the amount of spaces. Hold down Control again with the computed area. I don't know why it says computer. Nobody corrected me. No, I'm kidding. I'll correct it right now. Computed area. Okay. There. So we have it all down, right? So this is the only things that you don't see right here, these 3, or these 4. Let's go ahead and start working it out. Let's say we have a living area. Purpose of space, hanging out. Let's just make it simple, right? Amount of spaces we only need, let's say we're making a duplex, so we need two of them, right? Because a duplex needs two of them. You know what? Let's try to make it a bit simpler. Name of space, toilet. Purpose of space, relieving yourself, relieving self. Amount of spaces, so we need three of these in one house. Let's say three. Type of movement, we're going to be needing, let's say marginal movement. So we only need one. One person in the CR. We don't need more than one person. Don't joke with me, okay? I know you want to, but no. This example is only one person. It's only meant for one person. So first thing we're going to need is a toilet. Then we're going to need a sink. Then we're going to need a shower. Or wait, it's just a toilet, so we don't need the shower. X-nay on the shower. Toilet, sink. Width of the toilet, 0.45. Depth of the toilet, 0.7. Bam. And then here, the sink, we just, if we're going to have a small sink, I'd say 0.45 by 0.45. Oops, sorry, 0.45. I forgot to put this here, the X. We need the X to indicate that this is the multiplying spot, and we're just going to go all the way down to 1,000 again. Down, 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 down. There we go. 1,000. Okay. So toilet, sink, one person that's doing marginal movement. We need three of those. All right. So like I said, there are certain things that we still have to edit ourselves. And the first thing we need to do is merge these. So I'm going to go ahead and merge these. Merge, merge, and we're going to merge these as well. Merge, 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 and this one is going to merge as well. So it's going to ask us, it's going to discard the other values. It's going to keep the one at the upper left. So if you're going to if you're going to merge all of these, it's only going to keep this value. Okay. So these we don't have to merge. Obviously, it is what it is. Right here, we have to merge these. So merge. Yes, I'm fine with it. Okay. And here we're going to merge these as well. Merge and center. Consideration on multiplier. Let's say they just want to have an extra 20% space. Bam. Okay. So here, all right, we're going to go ahead and go way out into our nowhere land. So let's go here. Way out into nowhere land, and we're going to put equals sum. And the sum of these numbers right here, 0.32 and 0.20. Enter. So it's 0.52. Okay. And these again, we're going to merge, keeping the top. We're going to merge these again. It's going to keep the top. Okay. Oh no. I'm so sorry. We forgot to do this as well. All the way down to 1,000. 1,000. Right there. Enter. Back to the top. Now we're going to merge it. Merge and center. Okay. So this is supposed to be D4 times P4, 0.34, 1.72. So we have computed area for the space in square meters. Computed area with consideration in square meters. So this one we've made a mistake here. Once again, so what we're going to do is we're going to put product and open parentheses product 0, 4, and 4, because that's going to be the row that's consideration of multiplier, and the computed area for the space in square meters. Okay, and then we're going to close parentheses all of that again. And then we're going to add computed space right here. Okay? So actually, no. What I'm going to do is we're going to go ahead and go into nowhere land again. So I know you guys are kind of confused. I'm also getting a bit confused. But right here, there's a problem. If you did the math in your head, you can tell that 1.03 is not the total needed area in square meters. And the reason I was able to figure it out so fast is because of this right here, 0.34. 0.34 square meters is actually 20% of 1.72. So that's how I figured it out so quickly. What we're going to go ahead and do is we're going to go ahead and go out here in nowhere land. And we're going to go ahead and copy this format here and put it here on this end, right? Whoops. We're going to go ahead and unmerge that. There we go. And we're going to go ahead and say this is computed consideration multiplier. Okay. Column width 14. Okay. And so we already have the equation here. This is why we don't copy and paste. So this is just an example. It says W4 V4, right? And I got 0.52. So we have to change this. We're going to go ahead and say equals product. And the product is going to be this one. And then we're going to hold down control and this. Enter. Okay, close parentheses, enter. So 0.34. So now we got 0.20% of the computed area for the space in square meters. This is the consideration. Now for this computed area with consideration in square meter, we're going to change this into sum of computed area for the space in square meters. So we're going to go ahead and click here, and then we're going to hold down control, and we're going to click here out here in nowhere land, computed consideration multiplier, enter. Now it becomes 2.06. Now it's the correct number. So here is our computations. Now we can go ahead and just go ahead and roll these down to 1000. But the reason I don't do that is because my concern is this right here. You're gonna get a computation here, which is from this, right? Which is what we don't want to happen. But because this kind of gets confusing, but it's not gonna count here because this one, like I said, it's only gonna count the most top left item. So watch, if I undo that, this didn't change. So if you want and you feel like you're not gonna get confused, you can go ahead and do that. So we're gonna go ahead and do the same here. I want to point it out to you guys. That way you know what's happening in your computation table. And that's the same thing that's going to happen here. So there's going to be like these pop-ups here. So there you have it, guys. We have made a computation table. It's a stressful situation, isn't it? So here, we're going to go ahead and just put a border beneath. Bottom border, and then we're going to go to the lowest one here, bottom border. So this way, we can kind of separate what's going on. Here again, bottom border. Bam. So, what does this computation table show us? For let's say our project has 3 toilets for relieving ourselves, just relieving ourselves. For one of those toilets, we just need 1 person with marginal movement. So if you're doing other actions in your toilet, shame on you. So we got 1.2 square meters, right? We need a toilet and a sink. That's all we need. these kind of things, these width and depths, you can get them from your brochures, or you can kind of memorize the average width and depth of your fixtures or equipments or what have you. And over here we have 1.72. So how did we get this? 0.32 plus plus 0.20. It gets computed way out here in nowhere land. So let's go ahead and go out here. Out here in nowhere land, 0.52. We disregard this number 0.20. You just have to remember to disregard it. Always just keep track of the very topmost number, because that's the only one that matters in this whole equation. Go back. So 0.52 plus 1.2 equals 1.72. Good, 1.72. And we added a consideration multiplier of 20%. So we go back to nowhere land, way over here. 20% of 1.72 is 0.34 square meters. So we go back. So that's how we get this computed area with consideration in square meters. 1.72 plus 0.34 equals 2.06 square meters. And then we have 3 of these spaces. So total needed area in square meters. 3 times 2.06, 3 times 2.06 equals 6.18 square meters. So in the totality of our building, of all the spaces that we need, what we need for the toilets is 6.18 square meters. Now, let's go ahead and apply this in our in a small project. So let's say we have 1.72, right? What I'm gonna do here is just randomly outside here in nowhere land. Okay, let's go ahead and zoom in here. Randomly somewhere out here in nowhere land. We're just gonna pick a spot. 1.72. We're going to make a toilet room, a comfort room, using 1.72 square meters. Let's say that I want to have one of the dimensions of 1.2. Okay, so we're going to go ahead and go here, equals 1.72 divided by 1.2 equals 1.43. Okay, so now we have our two dimensions, 1.2 times 1.4. Okay, let me go ahead and switch to Sketchup. All right, so let's go ahead and make this happen, guys. 1.2, 1,200 millimeters by 1,430 millimeters. 1,200. Close that space just right there. This is our room. Okay, this is our space. Now, like I said, a regular toilet is somewhere between a width of 0.45, 0.45, so that's 450, right? And then 700. Okay, so it's kind of best that you know what you're dealing with, the equipment you're dealing with. I'm going to go ahead and edit this a bit. So the bowl in the back, sorry, this bowl is usually somewhere around 200, right? Then we're going to go ahead and go here in the center. We're going to typical seat is around 450. I'm going to make a circle. We're going to have there we go, circle. Okay. We're going to erase these, erase those, erase that, erase this, bam. So that's a toilet, right? No problem. Okay, I'm just going to put it off to the side. And then I've indicated that our sink is how many, guys? 0.45 by 0.45. So we're just going to say 450 by 450 sink. Bam. Make into group. Okay. For off the center, I want 300. Somewhere around there. Let's go ahead and make it another 100. Okay. Then we're going to move this up a bit. So how much space do we got here? Let's try to make it a bit equal on in terms. 175. Let's go ahead and just make this 100. Bam. So now we have some space to clean off the side. So let's just say this is like a standing sink, right? All right. So that's our space. Now imagine that this doesn't have a door yet, right? So for a normal toilet room, we have a length of 600, right? And let's go ahead and show the door here. Bam. Now we have a door. Awesome. Okay. And that is our toilet room, right? So we have all this right there. Bam. Door opens, all the space is there. People fit, whatever. So it worked, right? So this is a very comfortable toilet. Now imagine this also, we didn't even consider the thickness of the wall. So if we take that into consideration, we're going to move this all away from the wall. And we're going to move this. Let's say that the wall here is going to be somewhat in the middle. Okay, so that'll be fine. Let's say we'll move this one here. Bam. And then this one here, we're going to move this 75 because it's in the middle, right? This one here, 75. So for the toilet side walls, we're just going to go 75, 75. Here in the front, we're going to just make it 50. Okay. And so that you understand the thickness of the walls. The other half comes here. 75. And this is supposed to be the outside wall, right? So we'll just make it 100 because there's pipes going through this wall. So this is like without considering that we have the wall thickness, which is why I always I'm an advocator of adding um, a multiplier, a consideration multiplier. Okay, so right here, move that 50. Go ahead and fix this up. This is where our jam is. Move that 50. Bam. Let's get rid of the axis so you can see it better. Bam. Cue that. So we'll rotate it. Bam. See that? Barely. Barely. But if you imagine the edge of that sink would be kind of round anyway, so but it barely just such a tight fit. And with that, you can see that this area right here, the total area of that is 1.34. So that's because we didn't take into consideration the wall thickness. So if we take a calculator, 1.34, let's go ahead and go back to our Excel sheet, guys. Excel, because I want you guys to understand 1.34 divided by what's our 1.72? 1.72 equals 0.77. Sorry. Uh, 1.72 divided by 1.34. What am I doing? Equals 1.72 divided by 1.34. Equals 1.2. Is that right? No, that's not right. 0.77, is that right? I'm trying to get a percentage here. 1.34, 1.77. Well, anyway, let me get a calculator. 1.34 times 0.15. Calculator. 1.34 times 1.34 times 0.15. No, 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 no. 1.34 plus, okay, I got it, equals 1.34. I'm sorry, I'm getting blank here. 1.72 minus open parentheses 1.72 times 0.15 shift enter equals 1.46, 1.34. So there. I'm sorry, I was kind of drawing a blank. What I'm trying to point out here is that we have to take in consideration into the thickness of the wall, which I believe is somewhere between 15. For me, knowledge, experience would show me that it's somewhere between the lines of point 0.1 or 10% to point to 15%, 10% to 15% when we consider making our space programming, right? So uh, that's in the totality of the building. But since this is just a toilet room, comfort room, it's probably why I'm not getting the same output because the difference there was point 0.1, roughly point 0.1 square meters. But it does point out that wall thicknesses still take up a considerate amount of space. So if we go back here to the SketchUp file, uh, yeah, see how much space that took up, and that's not even considering the fact that this right here has to be thick enough to have the pipes, uh, the drainage, the vent, and the waste pipes embedded into it. Yeah, unless it's hollow. So it depends on how it's built. But yeah, this shows us exactly how it works. And so we have point 0.6, right? So if you guys remember, 0.77. Oh, sorry. Uh, 750 by 750. Okay. Um, bam, bam. We're gonna make a circle here. Okay. This is our dude right here. This guy right here is our points. This is our point 0.6. So he just slides in here basically. So if you imagine that, or actually it's 1.2, isn't it? Um, where is it? Go back to our Excel. We used 1.2 as our computation as a user, right? So let's go ahead and go back here. Right here. So we got one marginal movement at 1.2 square meters. That 1.2 square meters is like all of that, all of that open space right here. You know, bam, that blah 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 right there. So what if we didn't have the multiplier? That is an interesting question, right? Let's go ahead and go back to our computation table, guys. Okay, let's get rid of the multiplier. 0%, 1.72. Oh, we did use 1.72. I'm such an idiot. Let's go back. 2.06. So now this time we're going to use the multiplier. Why don't you guys correct me when I do stupid things? So this right here, this right here that I created, this is without the multiplier. This is how tight it is. Let's go ahead and add the multiplier. Let's go back to our Excel. Okay, go here in nowhere land again. 2.06, right? So what we're going to do is we're going to take 2.06 and we're going to divide that by, let's say 1.5. So 1.37. Okay, we're going to compare the two. Okay, 1,500 1,370. Okay. We are going to compare the two. Move this 100. Oh, sorry. 1,000, so that we have some space between them. I didn't switch the SketchUp. One moment. There we go. So these are our two comfort rooms, all right? Go ahead and move this by 100. We're going to move this by 100. We're going to move this by 75. We're going to move this by 75. And we're going to move this by 50, right? Bam. Okay. Let's go ahead and take these three right here. Oops, right here. Move that again, 50. Okay. We're going to take these two, move it 75. And we're going to take these two, move it 75. Okay. Good, good, good. So this is going to be our wall thicknesses. Now we're going to take all these objects again, the sink, the toilet, the door, copy them right there. Oops, sorry. Move that 50. So we're going to take into consideration the door jamb. We're going to make this into a group. Close that. Rectangle. Copy this. Other side. Okay, we have the jamb. This right here, we got the sink. Let's move it away by 100. This one, going to move it to the center. Then we're going to move it 400. Too much. Sorry. Oops, one more. 100 more. So move it by 200. How much was that? 400. What did I press earlier? Well, that's 400. So that's 400. That's correct. So you can see the difference in the space. $90. Look at that. Look at the difference in space between these two toilets, these two toilet rooms, comfort rooms. Which one would you prefer? So if you imagine the first toilet that, let's go ahead and move them closer so we can do a better comparison. It doesn't look like that much of a difference, right? Consider the fact that this is only 20% bigger than what it is without it. But look at that small difference. That's very small difference. If you go back to the computation table, and if we look at it, the difference between the two is a mere, let's go back into nowhere land, 0.34, 0.34 square meters. That's all it is, a difference of 0.34 square meters. 1.72 to 2.06 square meters. And we still took into consideration the thickness of the walls. So still taking into consideration the thickness of the walls, we can see here that, there's definitely a lot to be said to accomplish with that additional 20%, which is why, like I said, push as much as you can consideration multiplier, because that small amount of space will make the difference between living in comfort and living in misery, I mean, the fact that you can have a project built is already living in comfort, but why would you spend like millions on something that's just subpar? If you're going to spend, you might as well just add that additional amount just to make everything, just a bit better, because you get what you pay for, You get what you pay for. Imagine trying to close the door. So here you have to go all the way out here in front of the toilet just to close the door. And here you still have that space to kind of just squeeze in, you know. And here you have all this space in front of the toilet to begin with. You have this whole point 0.5 here. You got nothing going on for you, 0.35. Anyway, I'm going to end this video here. It's running a bit longer than I hoped it would, but that's kind of how it is when you're trying to teach things the right way, you know. As much as possible, I always try to, give as much detail. That way you can practice these things in your own lives, and uh, you know, if you're an architect, designer, engineer, what have you, uh, you can apply these methods in your own projects and, hopefully make something better than what you had expected to begin with. And hopefully you can also be able to explain it to your client in a way that they'll be able to understand by seeing these numbers, and then seeing the difference in the output, just like I showed you guys here, the difference of just 20%, you know. But anyway, uh, yeah, I'm gonna end this video here. I hope you guys enjoyed watching. I hope you guys learned something new. I apologize that it's a long video, but you know, I get excited about education, teaching people, and sometimes I tend to ramble on a bit, like I'm doing right now. But yeah, anyway, take care, everybody. I hope we can always better ourselves, and bye bye.